All right, welcome to our next lesson in our equations unit. This one is on solving addition and subtraction equations. And the whole idea behind this unit is something called inverse or opposite operations, basically doing the opposite to solve an equation. Now, a couple important pieces for us. First off, make sure we get our main idea here, the subtraction property of inequality. If you subtract the same thing from each side of an equation, the two sides remain equal. And that's going to be the whole idea behind these next couple of lessons is you're always treating both sides of the equal sign equally in order to understand how to solve an equation. Here's the biggest thing I'm going to tell you. No, you cannot solve these with mental math. I get it. They're easy equations. That's why we start with the easy stuff, but we're learning how to solve an equation so that when we get to the tougher stuff, especially in the 7th grade, into 8th grade, and into high school, we understand the steps that are involved. So these are not mental math. We are balancing the two sides in order to keep things equal. Think of it like you and your brother or sister. If mom or dad give you $5, they should give your brother or sister $5, or vice versa. You have to treat them equally in order to keep them balanced. So our first equation is w plus 2 is equal to 7. So some number plus 2 is equal to 7. Well, we're going to start by doing a drawing to represent it. Sometimes a visual is a good way of seeing something. And it looks like this. We have some amount w. So we represent it with a bar. And we're going to add 2 to it. So right from the end of the bar, we're going to add a second piece that's equal to 2. So w and 2 are combined together, and they equal, when we put them together, you'll notice the next bar is exactly the same size. The w and 2 together is equal to this part, because it's equal, and it's equal to 7. Well, if this wasn't such an easy mental math problem that we couldn't solve it another way, think about what you would do to try to figure out what w is. Well, w plus the 2 is equal to 7. So the logical explanation is get rid of the 2 to see what's left over. That's what we're going to do when we solve an equation. So we always start by drawing a line down through the equal sign because that shows us the two sides of the problem. And then the whole idea is that idea of inverse operations, doing the opposite. What did they do to w? I want to do the opposite. So we had some amount and then somebody added on an extra 2. Well, I just want to know what w is. I don't want to know what w plus 2 is. So I'm going to get rid of the 2 that they added on. I'm going to subtract that away. But our subtraction property of inequality says you got to do it to both sides. Adding 2 and subtracting 2 cancel each other out. They turn into a 0, and we're just left with our w. We got rid of that extra 2. 7 minus 2 is 5. And again, we know we could solve this with mental math. That's not the point today. Think of it like basketball. You're learning just to dribble the ball before we get ready to play the game. So we're practicing those little skills. So yes, you have to show all of that work. To do your check, all that means is you're going to plug your answer, 5, back in for w. So w, you're going to plug in 5 plus 2. Is 5 plus 2 equal to 7? Well, it is. So we know we solved it correctly. So let's try another one. W plus 8 is equal to 15. So we have some amount, y. I should know my letters better. I'm going to add 8 to it. So because they're being added, they go right next to each other, is equal to 15. So I want another bar that shows me that those two pieces combined together is equal to 15. That's how we show it in a bar diagram. The idea is, if I want to know what y is, I would take away that 8 from 15 to figure out what the other piece is going to be equal to. That's exactly what we're going to do in our equation. To solve an equation, you always ask yourself, what did they do to the variable? Well, they added an extra 8. So I want to do the inverse. I want to undo that, which means I want to get rid of those 8. So you threw on an extra 8. I want to get rid of them, so I'm going to take them back away. We had extra 8, but I took them away. So those are gone now, and I'm just left with what I started with, y. 15 minus 8 is 7. To do my check, 7 goes back in for y, so 7 plus 8 Is that equal to 15? Yeah, we're good. Same things works with decimals or fractions. Again, you're just solving your equation. Start with where the variable is, m. What did they do to it? Well, they added 3.5. So they added on something extra, so I need to make it go away. I'm going to subtract away that 3.5. But in order to keep my equation balanced, I have to do the same thing to both sides. So I'm going to subtract 3.5 from both sides. 3.5 minus 3.5 turns to 0. It drops out. Oh, that's just my dog. So all I'm left with is m. 12.7 minus 3.5. Well, 7 minus 2, or 7 minus 5 is 2. My decimal slides down. Here I got to do a little borrowing. 12 minus 3 is 9.2. To do our check, we're just going to plug 9.2 in for m. And here we can actually do the math. 3.5 plus 9.2. 5 and 2 is 7. Decimal slides down. 3 plus 9 is 12. That's what I wanted, 12.7. So I know I did it correctly. All right, last one here. Again, doesn't matter if it's fractions, decimals, whatever it might be. We just want to get y by itself. We want to know what y is. So they added 1/6. So I'm going to do the opposite. I'm going to get rid of that 1/6. 1/6 minus 1/6 is gone, turns to 0. So I'm left with y. 5/6 minus 1/6 is 4/6. But remember, with any fraction problem, always put your answer in the simplest form. So in this case, my answer would be 2/3. 4/6 can each be divided by 2. To check your answer, here's the one trick I'm going to teach you. With a fraction, when you go to check your answer, use the unsimplified version. That way you don't have to worry about finding common denominators again. So plug in 4/6 for y plus 1/6. Basically, we're just doing the problem now that we know what x is, or what y is. 4/6 plus 1/6 really is 5/6. That's what I wanted for my answer, so I'm good. All right, so let's try the same thing with subtraction. So you'll notice this time we have the addition property of 0, or addition property of inequality. Sorry, I shouldn't do these first thing in the morning. If you add the same thing to both sides of an equation, the two sides remain equal. So the idea is now we're going to use addition to solve our problems. And sometimes a visual will help. So we're going to draw our bar diagram. So this time I have some amount E. So some amount, I don't know what it is yet. And I need to subtract away 5. So I'm losing some of that E. So instead of adding it on, we're going to show subtraction by showing it right underneath. We use little dotted dashed lines there, and we show the part that's being subtracted away. I'm losing 5. Well, what's left over after I'm done? Well, I have 2 left over. So I had some amount E, I subtracted 5, so the E got smaller, and the piece that's left is just 2. Well, if you look at it, what would you do to find out how much the whole E was? Well, wouldn't you put the 2 and the 5 together? Wouldn't you add them together? Yeah, that's exactly what we're going to do when we solve it. Again, focus on your variable. What did they do to it? Well, somebody took away 5 from it, so I lost some. So I'm going to put them back. So it's kind of like you lost $5 and are really upset, so I'm going to give you that $5 back. You're going to go back to what you started with. So I did the inverse, the opposite, so those went to 0. You lost it, but I gave it back. So now we're just left with E. 2 plus 5 is 7. Then we check. Put 7 in place of E. 7 minus 5. Well, 7 minus 5 is 2. That's what I wanted for my answer. So I'm good. Let's do another one. For those of you who printed out your notes for me, I missed the number, so you need to add that equals 6 afterwards. But here we have z minus 19 is equal to 6. So we have some amount z, and I lost 19. So I'm going to show it right underneath the bar. I'm going to show that I lost 19. It came back from my total. It didn't get added to z, it's actually cutting in to z. and I'm left with 6. That's what's left over. Well, think about it. If I wanted to know how much the whole thing was, wouldn't I put these two smaller pieces together? Wouldn't I add them together? And that's exactly what we're going to do in our equation. Here, I subtracted 19. Somebody lost 19, so I'm going to put it back. I'm going to give you back those 19. But in order to keep my equation balanced, I have to treat both sides equally. Not an option. You've got to show me that work every time. You lost 19, but I gave it back to you. So it's kind of like you didn't lose anything at all. You just have what you started with, z. 6 plus 19 gives me 25. To do our check, plug it back in. 25 goes back in place of z. So 25 minus 19. And yeah, you actually need to do the work. This is how you check to see if you did it correctly, is if you get the right answer, you know you've solved the equation equally or correctly. So can't do 5 minus 9, so I got to do a little borrowing. 15 minus 9 is 6. That's what I wanted for my answer, so I'm good. All right, last two real quick. We're not going to draw our bar diagrams for these. We're just going to solve them. Again, focus on the side with the variable. What happened to z? Well, somebody took away 6.3. So to solve it, I want to do the inverse. I want to do the opposite. I want to put that 6.3 back. So I do the same thing over here. I lost it, but I put it back, so it's like it never even happened. And I'm left with z. 2.1 plus 6.3 is 8.4. To do our check, plug 8.4 back in place of z. 8.4 minus 6.3. 4 minus 3 is 1. 8 minus 6 is 2. 2.1, which is what I wanted to get. Last one, h minus 3/8 equals 1/8. So we had some amount, but then somebody took some of it away. So I'm going to put it back. I'm going to put back those 3/8 that we lost. But I got to do it on both sides to keep it balanced. That turns to 0 because I put it back. It's like it never even happened. So we're just left with h. 1/8 plus 3/8 is 4/8, which is otherwise known as 1/2. When I go to do my check, remember, use your unsimplified version. So 4/8 minus 3/8, is that really equal to 1/8? Well, it is, so we know we've done it correctly. So your practice is going to be to practice solving these equations. Yes, you've got to show all of that work, and then we're also going to practice drawing our bar diagram. So use the examples from your notes to help you.